the essential question is, how do you find the vertex of a quadratic function? We have 5 new vocab words, and there's kind of a lot of information right down for each one, but it's really important. Quadratic function is a nonlinear function with a U-shaped graph that's called a parabola. Standard form for a quadratic we worked with in chapter 8. It's f of x or y equals ax squared plus bx plus c. So what's important with standard form is that you have all of those terms on one side of your equation, and the other side is usually filled with f of x, y, or the number 0. The axis of symmetry formula is x equals the opposite of b divided by 2a. The axis of symmetry is the green dashed line in the picture, and what it represents is a symmetry line for the parabola. So it splits the parabola in half, where the right and left-hand sides are mirror images of each other. To find the vertex point is that colorful bullseye point on the picture. To find that vertex point, you take the value for x from the axis of symmetry, and you plug it in your equation to solve to get y. So you plug it into your original quadratic. You know what x equals from the axis of symmetry. Plug it in to find y. And the y-intercept, that's the easiest one to find. Where your quadratic crosses the y-axis is the blue and red circle on the graph, and that is found in the equation by the letter c, just the letter c. Okay, now when you're looking at a graph, you may be asked to find some information about the quadratic function. To find the vertex is either the highest or lowest point on the graph, and it's the only point that's on the axis of symmetry, the only point that doesn't have a mirror image. So looking at this graph, my vertex point is here at the bottom, and you can see where the x and y axis is by where the arrows are on the graph. So from the origin, my vertex point is to the right 2, and then down 3. So my vertex is 2, -3. My axis of symmetry. My axis of symmetry has to go right through that vertex. So my axis of symmetry is right here. It's a line, and it's a vertical line. Vertical lines always begin with the letter x. So my axis of symmetry is x equals the point where it crosses through the x-axis. Here's the origin, 1, 2 to the right, so x equals +2. Every point on that vertical line has an x-coordinate of 2. The third thing that we have to find is the y-intercept. That is where your graph crosses the y-axis. So using blue, here is my y-intercept. It is at 1. Y-intercept, 1. So that's how you find the information, by looking at a graph. Another example where you're looking at a graph, my x-axis, my y-axis, my origin point. So my vertex is 1, 2, 3 to the left, and then up 2 right here. So it is -3, 2. Vertex, -3, 2. My symmetry line has to go through that vertex, and again, it's a vertical line. So my axis of symmetry, if my origin is here, 1, 2, 3 to the left, so my axis of symmetry x equals -3. Notice that the x-coordinate of the vertex always matches the symmetry line. Always. And my y-intercept, where this graph crosses the y-axis, my y-axis is over here. So where this graph crosses the y-axis is right here, this point. So 1, 2, 3, 4, 5, 6, 7, negative 7. Down to 7 from the origin. So that's how you find your information from a graph. Now, from an equation, what we are going to do with our equation, we are going to identify A, B, and C. A is 3, B is 6, C is negative 4. Because they're all on the same side, we're ready to go. My axis of symmetry formula says x equals the opposite of b over 2a. The opposite of b over 2a. If b is 6, the opposite of b is negative 6. 2 times a is 3, so 2 times 3 is also 6. Divide those and x equals negative 1. That is your axis of symmetry. X equals negative 1. That is also the x value of the vertex, because the vertex lies on your axis of symmetry. To find the rest of my vertex, I plug in negative 1 where the x's are in the original quadratic. And then I use the order of operations to solve. Negative 1 squared is positive 1. Then I can multiply from left to right. And last, add or subtract from left to right. 3 minus 6 is negative 3, minus 4 is negative 7. So that's the rest of my vertex. So my vertex is negative 1, negative 7. My y-intercept is simply the value of c. So my y-intercept is negative 4. One more equation like that. When there is no coefficient in front of x squared, that means your value for a is 1. B is negative 6. C is 7. Axis of symmetry formula. Opposite of b over 2a equals x. The opposite of negative 6 is positive 6. 2 times 1 is 2. So 6 divided by 2 is 3. X equals 3 is my axis of symmetry. It's also my x-coordinate for my vertex. I can plug in 3. Notice that I always put it in parentheses when I plug it in, just to be careful with signs. 3 squared is 9, minus 18, plus 7. 9 minus 18 is negative 9, plus 7, negative 2. So my vertex is 3, negative 2. My y-intercept is simply 7, C. One more example. Same information as the last two. A is negative 2, B is negative 8, and C is 1. Axis of symmetry formula, x equals the opposite of b over 2a. The opposite of negative 8 is positive 8. 2 times a, which is negative 2, gives me negative 4. So if I divide, I get negative 2. X equals negative 2 for the axis of symmetry. Negative 2 is the x-coordinate on my vertex. When I plug it in parentheses again, we'll be very careful with our order of operations. You always do your exponent first. Negative 2 squared is positive 4. Now, when I'm multiplying, positive and a negative, negative 8. 2 negatives is positive 16. So the last step, negative 8 plus 16 is 8, plus 1 is 9. So my y-coordinate for my vertex is 9. Last, the y-intercept is C, 1. Now you can write a summary For day 1, for section 9.1, the summary should be answering your essential question. And your homework problems are actually on page 531 and 532, number 5 through 12, 28 to 36.